Hey guys, hoping all is well with everybody. In this video we're going to be continuing on with Chapter 2 Geology Terminology Review. Let's jump into our first definition. So our first definition is P waves. Now the P in P waves stands for primary. So these are primary waves. And these waves consist of rhythmic push and pull motion. In the direction of wave travel. Okay, now there are three attributes of P waves that I really want you to understand. And the first is that these are longitudinal. The second is that they are fast moving. And the third, last but definitely not least, is that they can move through both solid and liquid states of matter. Okay, so I kind of want to illustrate what we're looking at when we're looking at P waves. So let's say we have the Earth here, okay? And at the very central part of the Earth we have the core. Basically these waves are going to kind of look like this, okay? But the thing that's important to understand is when they go and change from a phase change of matter from like solid to liquid, there's going to be a bending of these waves. Okay. So this bending takes place. But one of the most important things to see here is that they can go through both solid and liquid states of matter. Okay? Alright, let's compare this to the next type of wave. Okay, the next type of wave is an S wave. And the S in S waves stands for secondary. And these are rhythmic side-to-side. These consist of rhythmic side-to-side motion that occurs at right angles to the direction of wave travel. Okay, now just like the last type of wave, there's three attributes of this type of wave that I really want to also hammer home. The first is that these waves are transverse. The second is that these are slow-moving waves. And again, last but definitely not least, is that these waves can only move through solid states of matter. Okay, now I'm going to draw our Earth again with our core. Now the thing to remember with these is they cannot go through liquids. Okay. Alright, so these are what the S waves look like in comparison to the P waves. They're slower and they can only move through solids. Okay, let's look at our next type of wave. The next type of wave that we have is a surface wave. And surface waves occur when P and S waves reach the Earth's surface they generate a third type of seismic wave. Okay. Surface waves occur when there's a almost collaboration, or when P and S waves both reach the Earth's surface. Okay, and they generate this third type of seismic wave. Okay, let's look at our next definition. Alright, our next definition is elastic rebound. And it is defined as rocks on either side of a fault spring back to a position of little or no strain at the movement of an earthquake triggering vibrations in Earth's crust. Okay. So we have rocks on either side of a fault that spring back to a position of little or no strain at the movement of an earthquake, triggering vibrations in Earth's crust. Now I'm going to illustrate exactly what's going on here with a set of 3 pictures. So let's say that you have a yard, and your yard's on a fault, and you have a rock fence. Now, this rock fence is set up like this. So you have this rock fence in the middle of your yard. Now, before an earthquake, basically what's going to happen is this rock fence is going to try to resist any kind of bending, or it's going to like bend to keep its like self whole as much as it can. But as the intensity of this earthquake increases, there's going to be a point where the tension and the resistance is going to be so much that the rock wall is just going to snap. Okay? So this is what we're going to look at in the second part. Before the earthquake, there's going to be this kind of bend in the rock fence, okay? And this bending, again, is trying to resist this from becoming apart or into, like, breaking, so to speak. But again, after so much tension, it's going to, the rocks on this fault are going to just want to move back to a position where there's little or no strain. So it's going to cause this rock wall to literally split in half. Okay? And again, it's all because there's only so much that this rock wall can bear and take. Okay? Alright, but that is elastic rebound. Rocks on either side of a fault spring back to a position of little or no strain, and then again it's going to make this vibrational impact. This spring is going to make a kind of vibration in the Earth's crust. Alright, let's look at one more definition, which is faulting. Faulting is defined as vertical or horizontal movement of rock masses along a fault due to tectonic earthquakes. Now, one thing I want you to keep in mind with this definition, faulting is vertical or horizontal movement of rock masses along a fault due to tectonic earthquakes, is remember that there's different types of faults, and we're going to be looking into those different types of faults as we move forward. But the general definition of faulting is vertical or horizontal movement of rock masses along a fault due to tectonic earthquakes. Okay? But I hope these definitions help you guys out. We have one more video for Chapter 2 Geology Terminology Review, and if you guys again have any questions regarding any of these terms, please don't hesitate to message me. I'd be more than happy to clarify anything for you. But I hope you guys have a great rest of your day, and thank you so much for watching. Take good care of yourselves. Thanks.